Here we have a story over here. We have to model this story into a sinusoidal expression. So let's understand what story is talking about over here. So basically, a little Hiro is riding on a carousel, spinning around. So at the start is the closest, where it says this over here, is closest to the wall. The distance is about 2 meters. So this is 2 meters away. And after 7 pi seconds, and he reached his midway point from the wall. So midway point. So we're talking about there will be a central line over here. So you're going around in the midway over here. So that's 7 meters away. So from here to here, it's 7 meters away. And yep, that's the story basically. So if we draw a little graph over here, let's have a look on what does it look like. So at the start, that will be the closest. So that's 2 meters at the start. And then after 7 pi, over here, I reach into a midway. So that's 7 meters. So hence you start from quite low down there, and that's the minimum point, and you go up. Okay, and we understand if the carousel is spinning around in the same speed, and after another 7 pi seconds, it will reach the maximum, which is around here somewhere, maximum. Okay, let's find out based on this and how we can write this as a sine or cosine function. Now we understand if you want to model a scenario into sine or cosine, you need to figure out what is A, B, C, D. Right? A stands for amplitude. Let's figure out what is A going to be first. So A is going to be from a minimum to the center line, or from the maximum to the center line. So because we know the center line is 7 and the minimum is 2, so 7 minus 2, let's give you 5, that's M. Okay, so also we know the center line over here, so hence we know it's move up to 7. And let's find out what C is going to be, since we're going to use sine, because that's where the center line is, and from sine, so we can see it's moved to the right by 7 pi. So hence C is equals to negative 7 pi, because it moved around, so you minus. Now period, we can see from the minimum to the center line over there is basically a quarter of the whole period. That equals to 7 pi. So hence the whole period is going to be 7 pi times 4. Let's give you 28 pi. Now we also know B is going to be equals to 2 pi divided by the period. So which is 2 pi divided by 28 pi. So that gives us 1 over 14. Nice. Now with A, B, C, D, we can figure out what this equation is going to be. So the distance, that's equals to 5 sine 1 over 14 t minus 7 pi, and the whole thing shift up by 7. Alright, so excellent. So number 1 sorted, we form the equation. Number 2, Mom actually stands on the other side of the carousel, and she can only see Hiro when he is 8 meters away from the wall. So if we can roughly illustrate the story, for example, Mom is standing around here, and Mom can only see Hiro when it's reached 8 meters away from the wall. So 8 meters away from the wall. So which means it's around 8 meters away from the wall. The question asking is, when is the first time that Mom can see Hiro? So that will be whatever the time that corresponds to the distance, which is 8. what is this time going to be. So hence we're going to use this model and solve when the distance is equals to 8. Now I'm going to use two different ways. Number one, I'm going to use solving the equation thing, and then we're going to use a calculator to solve what is the time going to be, right? So hence the whole equation equals to 8. So hence sine 1 over 14 t minus 7 pi should be equals to, you have minus 7 over there, so that's become 1 divided by 5 is 0.2. So hence it gives us a principal value over here. So let's use this. So that will be inverse sine 0.2. Okay, let's give you 0.21201. And then since we only look for the first time, so we don't really need to write down as a general solution. So we will have the first time over there. But for next time, we still have the next question. We still have to figure out quite long period of time. So hence, let's just write down general solution over here. Good point. So the whole thing, because sine, so equals to pi n plus -1 to the power of n times 0.201. Okay, so let's solve this. So t minus 7 pi equals to, you times 14 pi n plus, and that thing times 14, that's equals to -1 to the power of n times 2.819. Okay, I can move down a little bit. So we're going to plus 7 pi. So hence t is equals to 14 pi n plus -1 to the power of n 2.819 and plus 7 pi. Alright, so we're looking for the first time when mom can see little Hiro, which is the distance for Hiro away from the wall. It's going to be 8 meters. So we'll try to solve the question B. So hence, let's say, okay, when n is equals 0, what is time going to be? So we have t equals 2, that's equals 0, and that equals to 1. So hence we have 819 and plus 7 times pi. Right, so hence we have 24.8 seconds over here. Let's have a look whether it makes sense or not. So 7 pi is roughly about 21. Yep, 21.7 or 0.9. And so the next closest time and that reached distance is 8 is 24.8. So that's quite makes sense, right? It's close enough. Cool. So that's question B sorted. Let's have a look question C. Question C over here says the carousel runs for 10 minutes each ride. What is the total time that mom can see Hiro? So the total time. Let me see the highlight over here. So basically for one circle, when Hiro's sitting around, right, for one circle, the portion that mom can see Hiro is going to be around there, right? So everything over there is going to be 8 meters away from the wall. That's when mom can see Hiro. Okay, we want to find out that portion, how long it's going to be, what is time interval for that case. So hence, I want to extend on this graph so that we can see what's going on for one period. Okay, that's one period. And in terms of 8 meter, we can understand you have another solution over here. So everything covered in this portion, that's when mommy can see Hiro, right? So we want to find out what is the next time going to be. Since we already know one time is 24.8, we want to find out what is another one in the first period that give us the distance equals to 8. So hence, we're going to use a general solution over here. So when n is equals to 1, what is t going to be? So let's find out. t is equals to 14 pi plus, so actually it's minus because -1 to the power of 1 minus 2.819 and plus 7 pi. So let's find out. So 14 pi plus 7 pi is 21 pi. So 21 times pi and minus 2.819. Right, that's give us 63.15. Okay, that's close enough. So which means that number over here, that will gonna be equals to 63.15. That will be the next time in the first cycle, in the first period, that give us the distance equals to 8. So what is the time interval in between this? So we can see the time interval for one period, that's equals to 63.15 and minus 24.8. Let's give us minus 24.8. Okay, it's going to be 38.354 seconds. Cool. So this is only for one period though. Okay. How long is one period? Is right over here is 28 pi. So it's roughly 28 times 3.14. So that's give you 64, roughly around there. So that's one period. 64. Sorry, it's not 64. So it's 84 seconds. But we have 10 minutes around here, right? We want to find out how many periods going to be within that 10 minutes. So let's find out. So number one, we're going to use 10 minutes to divide by the period. We're going to find out how many circles. So let's write down over here. So the number of circles that the carousel will spin around, that's equals to 10 minutes, right? So hence we're going to 10 times 60, that will be seconds, and divide by 28 pi. And then we have 10 times 60, that's the total time for one ride, and divide by 28 and divide by pi over there. That's equals to 6.82 times. So which means the Hiro actually will sit on this carousel, spin around 6 times, and an extra 0.82 circle. So if we actually use highlighter over here, which means little Hiro start from here, you're going around once, that's one circle, right? Twice, come back 3 and 6 times altogether, and then go further around 0.82 circle. Where's 0.82 of the whole circle? So if you go around here, that's half, right? And then that's 3/4, which is 0.75, and 0.82 is roughly around here. So which means the last circle that Hiro goes is start from here and go around here, okay, and it stopped. So can you see it's also covered that period of time when the distance is more than 8. So hence, how many times that Hiro gonna pass on that zone, that place? So that will be 6 circle and plus 1 more time. So hence, that will be altogether 7 times. 7 times that Hiro will pass that distance is further away, 8 meters further away from the wall. So 7 times. Cool. So let's write down over here. So hence we know that will be equals 7 times. And so the total time should be equals to, so we have 38.354. So that's one time interval for only one circle, and times 7 times. So hence you should have 38.354 and time that 7 times. So that give you 268.478. That's too precise. Let's just run it up, and so hence we have 268.5 seconds. All right, that's close enough. Thank you so much.